Okay. So, hi everyone, and welcome to today's webinar with the RVE team, where we will introduce you to all the new products that are coming out of for the market this year. Really happy to have a moment with you today. Seems like we have people from all across the country for both Canada and the US. I'm not sure what time zone you're in, but hopefully you might be in the middle of your lunch, or maybe it's later in the day for you. But anyway, thank you for joining in today. We're giving this webinar out of Montreal, Canada, at this very moment. Before I start with the agenda, I wanted to let you know that if you have any technical questions or general questions, feel free to ask them during the webinar. Maybe we will reply to you directly in the chat, or I will answer those questions at the end during a Q&A period. Really hope you find the content of today's presentation useful for your practice. The audience for today's webinar really is for engineers and specifiers that are looking to understand more about electric vehicle and energy management systems or power control system, specifically tailored towards more of a residential application. So meaning for townhome application, for high rises where people want to charge at home, in buildings where typically their cars will be sleeping in their own dedicated spot during the night. That's really the focus of today's webinar. As a friendly reminder, I invite you to follow us on LinkedIn at Recharge Véhicule Électrique, where we post both bilingual content, both in English and French, and also on YouTube or Instagram at RVE _AV EMS. So today I will be introducing you all to the Hub, a new solution for building level energy management systems for electric cars, as well as the DCC Plus and the SMP, a smart metering panel that aims to make it easier to charge in multifamily building. The bigger intent here is to share a bit of the high level and more in-depth level of the technical specifications of the products RVE has developed over the last decade, basically, and hopefully help you design more efficient, more reliable, and more cost-effective projects for your clients. My name is David Corbeil. I am the CEO and co-founder of RVE. So for the better part of the last 10 years, I've been involved in this industry with the intent of making it more affordable and safer to do load management for electric cars and help the grid, help the infrastructure provide for better charging and better and safer reliability. Some of the commitments and implication from myself or the RVE team have been over the last 4 years with the establishment of the CSA 343 standard, so for electric vehicle energy management systems. RVE is also involved in the committee working on the UL 3141 document for the standard of power control systems. And I also happen to be on the subcommittee section 86 on electric vehicle supply equipment for the Canadian Electrical Code. So if we look at a few regulatory changes that happened quite recently, so in June of 2024 was the publication of the 26th edition of the Canadian Electrical Code, and also integrating clarification around some relaxations in Rule 1, in Rule 8, 106.11 in regards to power management. For the US market, in August 2024, was the public comment for the upcoming National Electrical Code to submit feedback, and the code is expected to be published next year. In September 2024, there was a draft public review for the C343 standard for EV/EMS that was published, which was one of the last few steps in order to be able to publish the standard. So most of the specifications are, quite available to design around, but the standard is yet to be published. And in the States, UL published in October 2024 a outline of investigation for its power control systems standard. So while it's not a formal public review, it's a way to show the industry where the standard is heading, and a great way for companies to start designing their systems accordingly, which is exactly what RVE has been doing for the last couple of years. So before digging too much into the topics of today's call, what is an EV/EMS? What is a PCS? Two terms that will be used on a daily basis. So for EV/EMS, under the CSA C343 standard, we're speaking of electric vehicle energy management system, which is a means used to control electric vehicle supply equipment loads through the process of connecting, disconnecting, increasing, or reducing electric power to the loads, and consisting of any of the following: a monitor, communication equipment, controller, timer, and other applicable devices. Then on the other end of the spectrum, with the UL 3141 standard, what is a power control system? Well, it is by definition an electronic device or assemblies that regulate, monitor, and control the distribution and consumption of electrical power. These systems are designed to ensure that power is delivered efficiently, safely, and reliably within a given environment. So while being a little broader and not only applying to electric vehicle supply equipment, the intent of both standards is to give a clear framework for OEMs to design around some really clear safety requirements and functional features that will protect, obviously, the deployment, and also for specifier to know, what are the right standard for the right application, and make sure that all the products are code compliant. All in all, the way we can synthesize what are those two systems, well, basically EV/EMS or PCS, they do three things. So they will enable some monitoring, some analysis, and some control of many different type of loads. In most cases, EVs. In some cases, maybe it's an AC or other components. While today's call will be really focused around EVs, there's definitely multiple loads that can be controlled through these with these systems. If we look at the components of EV/EMS, basically we will have the monitoring of branch circuit, feeders, transformers, main service. Then we have analysis, so it can be local or remote, depending on if it's a critical decision or not to be taken. Then for communication, we have wired, we have wireless communication, depending on the application. And then for the control part, we can do it through a branch circuit, a panel, an outlet, or a charger. In a nutshell, when what I think is important to remember is that when all the components of EVEMS or PCS are installed and certified in accordance with the code, the load of EVSC does not have to be included in the load calculation. For compliance to those standards, a question that arises quite a lot, and where RVE we are maybe more on the safer or more conservative side of the limits of those type of systems, is about where the decision making happens. So a question that comes quite a lot in the industry is, can the decision making of an EVEMS be located in the cloud? So while some decisions can be located in the cloud, everything related to critical decisions, so that will avoid dangerous failures for critical load management, where the latency must be within a really short time frame. We're talking about seconds. Those type of decisions must be taken by a local controller. It's quite clear in the standard, and that's the way RVE has designed all of their systems. A simple example that was used during the redaction of those standards are looking at elevators. Would we want a cloud controller to decide whether or not there's too much weight on an elevator before it can take off? I don't think so. So that's why all the critical and mission critical decisions for EVEMS must be taken locally, just like for elevators. The MB controllers regarding emergency braking, overload, or positioning will always be within the environment of the elevator, to make sure that there's a redundant circuit logic, which makes sure that there's no overload or failure. With all that said, I am now very happy to introduce you to the hub. So the hub of RVE is the very first EVEMS compatible with all charging solutions, which is a system that is agnostic to all the application. The hub is currently certified by SP 1000, where we followed the C343 standard for EVEMS. We're also in the process of getting the EVEMS standard, and it's going great. So in a nutshell, the hub will monitor and analyze the feeders at the more of the building level in order to provide us with the right information to make educated decisions in terms of control. So the hub will enable to monitor all types of feeders. So whether it's a setup where you have a townhome project of, I don't know, 20 units, and you need to monitor a service, where then you might be able to tap the power from the units meter. That's a solution that can be useful. But also when you have a dedicated shared infrastructure, maybe on the common area, or a dedicated meter for a bunch of EVs, the hub can also be helpful to monitor the upstream current. So the way the system is designed is that it will enable to do the analysis locally with the CT clamps, flexible or rigid. Then it will enable us to do the critical thinking and determine what are the best way to dynamically control the loads of the chargers while not being connected to Ethernet, which is a key feature in order to minimize recurring costs and basically have no recurring costs. Make sure that the local data are stored on the system and that all the mission critical decisions are happening locally. The hub is able to monitor up to 7 feeders or 15 flexible CTs, which can be both rigid and Rogowski, which is a lot of flexibility in terms of retrofit installation, where oftentimes it's harder to position those CTs. The device can control up to 120 DCC plus and up to 30 SMPs. So we're talking about small but also large-scale deployments where power is limited that can be enabled with the hub. If connected to Ethernet, it will give access to users access to our RVE portal. While designing the hub, what we did also was to include a screen for visualization purposes mainly, where the value of it is that we store locally 12 months of historical data, 15-minute peaks. Meaning that if you are having a hard time to gain the utility meters data, in some jurisdictions it's a huge challenge, or you want more precise data of your peak within a building to do a AV-ready plan or an electrical planning report. Well, the hub is also designed for that. So that's a great way to complete the analysis phase when you're looking at an existing building and you want to know from every feeders what's your current peak, so you can then plan ahead in terms of power available. So instead of using maybe theoretical drawings or utility data, the hub can be really useful just for that, and then be used to control the loads downstream. It will provide you with all the data you need on the RVE portal. So you can extract your 12 months data according to Rule 8-1068 for 12 months historic data according to the Canadian Electrical Code. In the US, typically it's 30 days. So you can also extract a 30-day peak of the last 12 months, for example. So you can really start from there and adapt your infrastructure and the new loads that you need to add. We have plenty of technical documentation for the hub available, really designed to help you understand the systems, how it works, how it is to be used. That's a system that has been out there on the field for over a year. We have dozens of successful projects already completed. So we're really at the phase of scaling up the marketing efforts and the sales efforts of that solution that hopefully will really help a lot of buildings to reduce their services and maximize their usage. We have also a simplified ordering process that we've put in place to make it easier to spec the product and order it, because it can get messy. So the system works for 4 types of applications. So for 600 volt 3-phase, 480 volt 3-phase for the US, 208 3-phase, 240 volt 1-phase. So really large spectrum of application into what we can monitor. So we planned a kind of a little case study to showcase how would the ordering process look like. So on the screen we have a simplified single line diagram of a single phase 120 240 volt main service that we would like to monitor. So that would be the main service, and then 3 single phase sub feeders for a total of 4 feeders that we would like to monitor. So oftentimes the sub feeders are underrated, or the service is underrated for the 3 sub feeders. So we might need to monitor all 4 feeders. So in this context, we would be on the context type number 4, a single phase 240 volt setup. We would want to monitor 1 main service, 3 single phase feeder. So when specing or ordering a unit, the customer would need to buy a 1 hub 15 G1, and sorry for the mistake, it should be written 4 hub feed G1 with a configuration of 413. There's a little typo on the screen, but all in all, it's super straightforward to order a unit. All the units will come with CTs. So we have, by default, we have Rogowski CTs, typically up to 1000 amps, but we provide options for up to 5000 amps at no extra cost. So those are all included in the pricing. And the beauty of Rogowski CTs really is typically for retrofits, but even for new constructions, they are way easier to install. They are also UL certified and CUL, so compliant to code in order to install them in the different environment that they need to be deployed. And as I said, the CTs come with the hub at all time. If you have any questions or need support, easiest way to reach out with the team is through sales@rve.ca. We have teams locally in Eastern Canada, Western Canada, and also in the US. So happy to discuss about any specifics for projects. Just send us an email at this address and we'll be in touch with you really shortly. So that covers the first part of the presentation today, which is around the hub for multiple application in multifamily buildings. Once the hub is understood, the next step to control the chargers is the control system. So I'm going to introduce you to the SMP and the DCC, two products that will enable the control of the chargers in various contexts. So first and foremost, the SMP. So the SMP is a smart metering panel that can control various capacities, so up to 21 chargers, typically on a 3-phase setup. It is certified for kilowatt-hour billing, so Measurement Canada certified. We handle all the paperwork for our customers so that they can provide with better transparency and equity the billing. It is a compact solution, so only 24 by 48 to control and manage up to 21 chargers. And really important, it's compatible with all brands of panels. It's compatible with all brands of charger and charging stations. So oftentimes the property owner, they don't want to own the chargers. They're not in the business of managing and operating chargers. So the way we've designed the system is that typically the property owner or the condo home association will be responsible for the SMP, which is a robust and industrial solution, but the chargers will be owned by the renters or the condo owners so that the association doesn't have to manage those. The SMP Plus is designed for multi-level energy management system. So in more complex and larger buildings, it can act as almost as a building management system in order to prevent overload at multiple points. It is equipped with a fail-safe features that allows relays to be opened in the event of a software failure. That's a really important point. Fail-safe will be key in the way systems are designed to enable you to use relaxation of Rule 8.106.11 that provide you the opportunity to offset the load of EVs in your load calculation. And for that to be valid, the fail-safe feature is extremely important, and that's something we have included in all RVE's products. For internet connection, if you have it, we will be able to provide real-time monitoring of consumption data on the portal. And within the product, locally, we have a optimal algorithm, meaning that we can predetermine fair energy distribution across all users, given a fixed or variable period of time. So for example, we will look at the amount of energy received by a user, in order to decide which user should receive power next and make sure that in the morning, everyone is fully charged. In terms of technical document, we have a technical diagrams requirements available for engineers. Just contact our team if you need access to it, with all sorts of diagram to make sure that you have all you need about our products. In terms of a typical setup, so the way the system is designed is that SMPs that can power up to 21 chargers can be deployed. So you can put multiple SMPs on one distribution panel. You can put multiple SMP on one transformer. You can daisy chain them. So really to create a large group of chargers. And also by monitoring the upstream, you can fully offset within the load calculation the load of as many chargers as you want. We're talking about hundreds of chargers that can be dynamically throttled depending on what's available at the service level. So that's a huge milestone for electrification, hopefully, to provide multi-level energy management system safely and reliably. Also, for electrical safety reasons, we handle all the limit and threshold when we set the products at the factory before shipping them, so that the end users or the customer on site, they cannot change the threshold limit of a SMP. That's something we do internally to make sure that when we ship a product, we are certain that they meet the specs that were given to us at the order phase, and that we respect all the code requirements. So if there's any request, solution is available right now. You can write us at sales@rve.ca. For the billing aspect, which is oftentimes a big hurdle in multifamily application, so we provide with a quarterly report that is handed to the end users directly from RVE. If that's enough for the customers, we also are able to integrate through API to condo manager software. So depending on the platform used by the end user, it's a really straightforward integration. And once that's in place, there's basically no fee for the billing for the customers, and better accuracy in terms of kilowatt hour billing with Measurement Canada certified systems like the SMP. So really a way to try to bring costs down in terms of operations and the billing aspect. That's in the center of our development of products. Okay, so that was it for the SMP. I'm now turning my pitch to DCC Plus. So the DCC Plus, again, I believe most of you know about the DCC, which has been our flagship product over the years. So the DCC is the same product with a plus. Basically, it enables to have a connection to the hub through a backnet, and enabling us to do multi-level energy management system, typically used for townhomes where we have accessible meters, low rises, row houses, plex. That's really where the DCC is typically used, because the meter or the breaker of each units is accessible near the parking lot, and that's just easier and makes more sense to take the power from them, from that place. So the DCC Plus in a nutshell is compatible, retro-compatible with all DCCs, can be used in individual mode, just like the classic DCC, but also connected to the hub. Will stand out because it enables multi-level energy management system, and the hub will locally control the DCC Plus if we have a risk of overload at the service transformer level, or even at the grid level. If I get into more of the technical details, so the backnet connection between the hub and the DCCs can go up to 2,000 feet in a daisy chain configuration. So there's almost no limit in terms of the length between the hub and the last DCC. 2,000 feet is quite a lot. You have the spec on the screen about the cable that needs to be used. Will be in daisy chain, so it's just one wire going out of the hub to all the DCCs. We have 2 backnet ports on the hub, and each backnet port can handle up to 99 DCC. Reason being that we need to give a single unique address to each DCC, and we're limited to 99 per port. We have 2 ports, and in total, we're currently able to do up to 120 DCCs per hub. So that's the limit we have right now. If you have projects with over 120 units, we could put 2 hubs to make it happen. Then, if there are projects that are currently out there with DCCs, we are now providing with upgrade kits to take a DCC Gen 2 or 3 and upgrade it to DCC Plus. So I thought it would be useful to showcase a real-life example of how some of those systems can save a lot of dollars. So we have here a building that we retrofitted a year ago. That's a building that was built about in 2015. And the HOA, the homeowner associations, wanted to have the building fully ready for electrification. So when they received the first quote from the electrician, they received a quote to upgrade the service, basically. That was put aside because that would meant just for the service upgrade, it was a $500,000 cost without even installing the chargers. So it was out of the question. When RVE came along in the opportunity, we were able to design a system where the hub would enable them to keep their existing service, maximize the power output in off-peak hours, and also from an electrical safety, enable them to go take some power at places where they could not do it before because they didn't have the systems to do it and the proof that there was actual power. So we deployed 160 DCC 9 Plus. We deployed a hub monitoring 7 feeders. And all in all, they did not have a new 1200 amp service to deploy. They saved $500,000 just for the infrastructure. And there's now over 50 electric vehicles charging on a daily basis. So a really high adoption rate. It's been over a year and a really successful experience. And you can find more details about this case study on our website that are available with testimonials from customers. So in a nutshell, all the products provided by RVE, whether it's the hub, DCC Plus, or SMPs, are compatible with any distribution panel, whether it's Siemens or Schneider or Eaton, and they are also compatible with all EV chargers on the market. So other systems are charger agnostic in the way they are designed and tested. In terms of availability, we have pretty much all products are available now. If you need more details about technical requirements or you want to set up more specific calls with the team, feel free to write us at sales@rve.ca or sales@rve-usa.com. We currently have about 100 hubs available now, and 300 coming by the end of the year. We have RVE kits available now. And for the SMPs, from when we get an order, it's about a 12 weeks lead time for delivery. For more in-depth technical support, you can write us at support@rve.ca or rve.usa. support@rve-usa.com. So it was a pleasure to present you today's product line. I hope you learned a few things and that it was useful, and happy to engage in more conversations in the future about electric vehicle energy management systems or power control systems. So that's it for today. I hope for those of you who are on lunchtime, you had a good time, and I will stay on for a couple minutes if there's any more questions, and I will be happy to reply to you all. Thank you very much for listening to today's presentation. Okay, so one question is, how does the algorithm works for the SMP? So for the smart metering panel, basically the way it works is that we have monitoring point for all the chargers. So we know how much energy was distributed in the last 12 hours. And from that, the system decides which charger to prioritize, and also based on the phases, because we're also taking decisions based on whether a charger is on phase L1 and L2 or L1 and L3. So we make sure we balance the phases accordingly when we decide how to deploy. Another question is, what was the budget cost for your sample project with 160 chargers? So what they did for to protect the service, so instead of upgrading the service, which would have cost about $500,000, they did put the hub in there. All in all, with the installation, it was about $20,000. So that was for the monitoring part and the hub itself. Then they deployed the infrastructure for 160 units. That was about $1,000 to $1,500 per unit. Doesn't include the chargers. It doesn't include the full installation. But for the infrastructure part, they ended up being around $1,500 per tenant or per condo owner. Another question, what happens if there is an internet communication failure? Great question. So all the systems deployed and designed by RVE will work for all their critical and safety decisions, even if there's no internet. Meaning that if Rogers goes down or the Wi-Fi is out, all the safety decision or critical decision will happen. If ever there's a miscommunication locally, then we have a fail-safe features in place that would open the relay and stop the charging. Another question. So I think I'll just share my screen for a typical, excuse me, typical setup of SMP. Great question. So in this context, why would the hub monitor the main service rather than monitoring the transformer that is feeding the EV infrastructure? My simple answer, frankly, would be We can do both. We can do just the main service or the EV infrastructure. So the SMP could monitor the upstream PSVE panel in this case and make sure that we don't exceed that power. It really just is for the illustration, but we could also monitor the distribution panel and make sure, let's say we have a 400 amp bus bar on this PSVE panel, then we would make sure that we don't exceed that power limit. Pleasure, Alexei. So are there any more questions in regards to products? Seems like we don't have any more questions. So I will thank everyone for joining in today. I hope it was a useful training, that you learned a few stuff about EVEMS and power control system. My name is David, and I hope to see you soon in the near future. Thank you very much, and have a great day.